Oh, and welcome to section 8.3, which is going to be on geometric sequences. Okay, and again, just so that you are aware of it too, thanks for checking these out. I know it's kind of been a process getting this all done, but this is for my college algebra class that I teach. But thanks for checking them out. But anyway, this is on geometric sequences, and what a geometric sequence is compared to an arithmetic sequence. Arithmetic sequences add or subtract the same number every time. Geometric sequences are going to multiply or divide by the same number every time. The formula for geometric sequences are a sub n, a1 times r to the n minus 1. And just like the last section, A1 refers to the first section, or first term, sorry. And the R stands for the common ratio. This is the number at which you are adding or subtracting, or not, multiplying or dividing by the same number every time. A lot of times you can find that ratio by taking the second term divided by the first term. Or in this case, any two consecutive terms. You take the higher term divided by the lower term, as long as they're consecutive. And what I mean by that is if you had like the 9th term and the 10th term, you could find the common ratio. If you had the 29th and 30th, you could find the common ratio. If you had like the 30th and the 5th, you'd have to do a little bit more work than just divide them. So just so that you are aware of it. But that is the formula for them. Very similar to what we did on the last section, where it's going to give you some stuff like a 2, a negative 10, 50, negative 250, bop, 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 and it'll ask you what's the equation. Well, first of all, the equation starts with the number 2, so that's the first term. Then, how do I get the ratio? Well, if I take the second term, which is negative 10, divided by 2, I end up with negative 5. So that is my ratio. Okay, and all I did was take this term divided by this one. If I would have taken 50 divided by negative 10, I would have got the same number also. So just so that you are aware of it, that's how I'm going to end up doing those. Another option, or another one, would be if I were to have something like this. And I know a lot of people grumble and moan about fractions, but unfortunately they do stick with us. But it's the same process. For this example, the first term would be 1. The ratio, if I take 1/3 divided by 1, I get 1/3 and minus 1. Now, just so that you are aware of this, how I got the 1/3 is I'm basically taking the second term divided by the first term, but also that's the equivalent of dividing. When you divide, you're actually multiplying by the reciprocal. So when I would have said, maybe instead of saying divided by 3, we're actually going to say times by 1/3. So anytime it actually divides the number, you're actually going to write the reciprocal of it, and it's going to be a multiplication, not a division. Okay? So again, kind of the same, along the same lines. If I were to give you something like this, and the directions would be find the common ratio, what's the first term, the nth term, and the 8th term of this. Okay, I forgot the 3 dots at the end. So first of all, the first term would be 5. The common ratio, how do I go from 5 to 15? Is I multiply by 3. So my nth term is 5, because that's my first one, 3, because that's my ratio, and minus 1. Now, one of the ways to get the 8th term is I could continue multiplying by 5 until I get 8 numbers out there. Or, since you just came up with this formula, you could actually type it in, and with your calculators, whatever 3 to the 7th is times 5, you actually could get a very nice or very easy number. Ugh, my calculator's not working. I gotta use my phone today because I don't have my graphing calculator for that. So 7, and I end up with 10,935. Okay, so again, that's one way to solving all those questions. It might give you a couple different things like that, but that's basically how you're going to end up working with them, is finding that out. Much like the arithmetic ones, if they ever give you something like the third term is 63 over 4, and the sixth term is 1701 divided by 32, find the formula for this. Again, right now, whoops, you would have put in 3 to get out 63 divided by 4. So you don't know the first term, you don't know the ratio, but it would have been 3 minus 1 up here, which 3 minus 1 is 2. Over here, same thing, 1701 over 32 equals A1 R, but this time you put in 6 to get that. You get A1 R to the 5th. Now, last section we could do the elimination method like we did in section 1 of chapter 5. This one we're going to have to do again something from chapter 5 section 1, but this time we can't use elimination because we're not adding and subtracting. We'd have to actually use a little bit of substitution. So what I do here is I always solve for the A1, and I'm always going to do it for the smaller r. So if I'm dividing that by that, I get 63/4 divided by r squared equals A1. So what I'm going to do is I'm going to put this into there, and I'm going to simplify it out. So 1701 over 32 equals 63/4 divided by r squared times r to the 5th. Now, using my exponent rules, if I have 5 r's on the top and 2 r's on the bottom, that means I have 3 r's left over on the top. Then multiply by the reciprocal in order to get rid of the 63/4. So that all cancels out. So you have r to the 3rd equals, that cancels down to an 8. And this cancels down to a 27. So I end up with 27/8. And then to get rid of a cubed, I cube root it, which means put the 3 in the crack of that radical symbol like that. And when you have that like that with a fraction, you got to do the top versus the bottom separately. So we're going to do the cube root of 27 over the cube root of 8. And the cube root of 27 is 3, and the cube root of 8 is 2. So there's my ratio. In order to find our A1, then I'm going to stick that 3/2 back over into that formula and then figure that out. I end up having, this is kind of a mess. I'm really sorry about this screen because it gets kind of confusing. But if I were to multiply 3/2 times 3/2, I get 9/4. And when you're dividing, you end up multiplying by the reciprocal. So if I flip that over, I end up canceling out the 4's. This cancels down to a 7. And I end up with my A1 equals 7. So my final answer is 7. And then my ratio was 3/2 and minus 1. And then once I have that, I can find out whatever I needed to. These are kind of messy because of the fact that you're going to have fractions in here. You just got to take your time and work slow. This screen is kind of a mess, and I apologize for that, but that's kind of the limitations of using an iPad to draw this, as I don't have a bigger screen for that. But that's how you'd end up solving it if you were given two terms that aren't consecutive, in order to work backwards on that part. Then the next thing that they're going to have you do is find the partial sums. Again, very similar to the partial sums in the arithmetic one where they give you a formula. This does too. Oops. It's supposed to be an R, not an N. Okay. So for this particular thing, I've got A1 and I've got the ratio and I've got how many I'm going to do. So when it says find the partial sums of the first 10 terms or something like that, then whatever your A1 is, let's say they give you the pattern like 1, 4, 16, and it says, find the first 10. Your first term is 1. The ratio is they're multiplying by 4, and you want the first 10. Then from here, put this in your calculator, see what you get. And with your calculators, be very careful with the parentheses. For me, if I'm using my TI, which I'm not today, I would put a parenthesis and then a double parenthesis. And the reason for this is the whole thing, and this is just the top. 1 minus 4, caret 10, close it, divided by 1 minus 4. Or if you physically said, you know what, I know 1 minus 4 is negative 3, that's fine too. But as long as you type that in like that, you would get the whole answer. And me not having a graphing calculator today kind of stinks because I can't actually give you the answer because I don't know what 4 to the 10th is. That's kind of the main thing for that, is not knowing that one. I can figure this out on my calculator on thing. No. Okay, I didn't get it. 4 to the 10th is 1,048,576. And then if I took 1 minus that answer, I get negative, all that, divided by negative 3 times 1, and I would have got 349,525 would be my answer for that. So just so that you are aware of it, that it's kind of one of those formulas that if you're finding the partial sum or the first so many terms, that's what it has. If they ever ask you to find the infinite geometric series, which means that it goes on forever, when you see something like that with infinity on the top, then that also has a formula where it would be A1 over 1 minus R. The only time that you can use that is if the ratio is less than 1. It's the only time. If the ratio is greater than 1, it will not work. Okay, so if you are given something that has a ratio that is less than 1, then you can put it in that formula. If it's bigger than 1, you can't do it. Okay, so for instance, if I had something like this that had the infinity symbol at the top, first term is 3, 1/2. Okay, minus 1. Okay, again, this is kind of in that general format where this is A1, this is the R. It's going from start to stop. This ratio is less than 1, so therefore I can put it in. So A1 would be 3, 1 minus 1/2. So in this particular case, 1 minus 1/2 is 1/2. And 3 divided by 1/2 is 6. So my final answer for that whole thing would be 6. If they ask you to find the sum of the infinite geometric series. If it doesn't say infinity, then they're going to tell you a number to stop at, and that's a partial sum thing, and that's a different formula again. So anyway, that's section 3.